All right. So that's what the ICMP does. It's responsible for messaging, and one of the for example, Traceroute also uses ICMP messages. That's how you get messages if a certain route is accessible or not. So there are ICMP4 messages and ICMP6 messages. They're different. Well, they does the same thing, but they're different. And these messages are used to see if the host reachability, or if the
Sir,
the
are you presenting or?
oh, I'm not presenting, sorry.
Yeah, I was wondering.
Yeah. Oh, okay. So
It's Friday.
it's Friday. Yeah, it's just okay. The recording is wrong now, but anyway, it's just for you guys, so you know. Anyway, doesn't matter. Okay, so it sees the so it checks the reachability, exact timeout, whatever. The you guys have a lot of practice with the ICMP messages, right? So now, so you ping from one host to another host, right? And like just this lab that you're doing about packet 6. Uh, so if you ping from H1 to H2 and the destination host is unreachable, how are you going to troubleshoot this problem? How are you going to start? What you going to see first? You ping from H1 to H2. Just like in the lab, you ping from sales server to CAD server and it did not reach its destination. How are you going to start troubleshooting? What are you going to see first?
Cable?
That's okay. You should check cable, but for Zane, that's not the first thing you should check. Okay. So first thing, okay. So cable, good. What else you gonna check?
Check the connection to the default gateway.
If the default gateway is correct. Now, how you gonna check if the default gateway is correct? You're just gonna. So that means you will type IP config.
Pin debug gateway.
Okay. Exactly, you're gonna ping, but first, before you, how would you how you're going to check the if the default gateway address is correct is by using ipconfig command, right? So you ping first thing, like okay, you can use any approach, but for me the best approach is if I ping is if the destination host is not reachable. First thing I will do is I will just type ipconfig to verify the IP addresses because this is the easiest. Checking for cable is more difficult than just type ipconfig, right? So I'll type ipconfig and there, as Jungu says, I will check the default gateway. If everything is correct, right, and the host is still not reachable, then it's a problem. Then what are we going to do? So then we're gonna check the cable, right? And if you see the light, and in Windows it tells you if the cable is disconnected or not. So anyway, you see the light is there, the cable is good, all your IP configuration is correct. Then you have, because I want to know you know about all the tools that are at your disposal to troubleshoot problems. So IP config. What other thing can go wrong in this case?
Sir, if the line is not up.
Yeah, maybe so okay. What I mean is, so you divide and conquer, because since H1 is in a different network, the problem could be with the routers, your router here, or the problem could be with this router. Problem could be with this switch. Problem could be with H2. So you need to use divide and conquer approach. So you check the cable. You can also your IP configuration is correct on H1, so you leave these two options out. So you're not gonna bother with H1 and the cable problem. What I would do next is I'm gonna ping this computer since it's in the same network. If it pings this computer, that means I have local connectivity. So the problem is with the router. This is how I troubleshoot. Okay, so it pings the local computer. Perfect. Then I'm gonna ping the default gateway. If I get the reply from the default, if I don't get the reply from the default gateway, then I'm gonna focus on the router. Then I'll go to the router and what I'm going to check when I go to the router. Assuming the default gateway failed, the ping to default gateway failed, what I'm gonna check. I'm gonna check the IP address of the interface that is connected to this switch. So G0, the default gateway. So I will type show IP interfaces, right? And it gives me the IP address of each interface, G0, G1, or S0, whatever. So if the IP address is not correct, I will fix it. Maybe there's a typo, there's some mistake. Maybe the interface is down for some reason. Maybe when you configure the interface, you forgot to type no shutdown command. Okay. Oh, sorry. Maybe the cable between this router and this switch is broke, have problem. So you see, just knowing what ping command does is not enough. How to use, just knowing hammer, well, I don't know if it's a good analogy, is enough. What does it do? How to use it in different situations to fix different things is the real skill. So then you ping the router interface. If there's no problem, then from here, so once you correct it, oh sorry, and you don't see any problem with this router interface. The IP address is correct, interface is up, no problem. So why it's not reaching H2? Then the problem could be the routing protocol or the other router. Maybe the route is not added for some reason, okay? Or you did not configure the routing protocol, which is the topic we will cover later, so always remember, whenever you're pinging a device that is on a different network, always ping first your default gateway or the computer in your own network to isolate the problem, because it's much more work to just go and fix the problem on the router. Like not just one router, two routers, right? So yeah, if you, and also, oh sorry, one thing I forgot. You ping H1 to H2, no reply. First thing you should do is, sorry, slipped my mind, I would ping another computer on the same network to see if the problem is not just with, maybe H2 is down or something wrong with H2, okay? Uh, so, for example, I couldn't print the other day, and it's a network printer. So I ping, there's no reply, right? From the printer. And printer is in the other room. So I have to see if is the problem is with the printer or something else. So I ping another computer on the same subnet, which I know is up. It's a server, and I get the reply. So I know the problem is with the printer. Then I had to go to that other room, and the printer was off. Okay, it's an old printer. It doesn't tell you if it's on and off. Usually, the newer printer, they tells you, you can see it, it's online or not. So it was off. Okay, Instead of troubleshooting the router, whatever, I knew the problem is. So this is how you troubleshoot, guys. Okay, remember that when you are troubleshooting connectivity problem, you have to go step by step. You have to use the divide and conquer approach. All right. All right, so this is, you already know, host unreachable, protocol unreachable, port unreachable. This is beyond the scope of source addresses, address unreachable, port unreachable. If you're pinging a firewall, this is something you might have to cover on your own later on, because you can also ping a specific port. Well, I don't know if you guys know what port is. Did we cover that? Have we covered ports? Okay, traceroute also use the command ping, and also tells you, give you if the time exceeded. Because traceroute, what it does is it has to receive a message from the destination in a specific amount of time. Okay, otherwise it will just wait and wait. So if it does not receive, it says if the time exceed, you will not see the reply. And time exceed for many reasons. Okay, when you're using when you're pinging let's say a Google server outside, maybe the Google, and you don't get a reply, don't think that there's no reachability. The problem, some lot of routers and lot of servers on the internet, they block ping, because ping command can be used to bring down your server. Okay, you can use a program that ping request like millions of requests every second, and your server or your router gets so overwhelmed that it cannot respond, and because the memory is bogged down, so it's the whole device just shuts down. So a lot of administrator, a lot of devices, they on the internet, they block ping requests. So if you block the ping request, so if you ping the device on the internet and you don't get the reply, it doesn't mean the device is not working. It's because it's blocked. Now you should also, so if you're managing a wide area network, if your company has multiple sites and they have multiple routers, you should also block ping from from outside of your network. Now, what happens if you want to test connectivity and you block the ping? So how are you going to test connectivity? For that, there's a feature called access control list in routers. This is an advanced topic which we are not going to cover in our program, but those of you who are curious, you can Google it and maybe learn later. Access control list, where you can allow one person a specific service and disable for everybody else. So you can allow, let's say I can allow myself to ping to a server or a router, but disallow other people. So ICMP has some new features and improved functionality. ICMP version 6 messages that are not found on IP version 4. So messages between IP6 router and a device, they also include dynamic address education. Okay, there and these addresses are router. Uh, uh, sorry, these messages are RS messages, meaning you're soliciting a router, you're looking for a router, and then every router also advertises its presence on a network. Okay, to the neighbor, like whichever device is connected to the next router in IP version 6. It creates a little bit network traffic, but this way you can discover IP service, IP version 6 routers that are enabled with IP version 6. So they're sent by every 200 seconds. That provides addressing information, and they can also include, so this is like DHCP, they can also include the prefix length. What is the prefix length? Is number of bits are used in for number of bits used for network portion. So usually you will not see more than 64 bits. Okay, and it can add DNS address and the domain name. And if a host is configured with stateless address SLAAC, it will set a default gateway to the link local address of the router. So this router's link local address is FE8001. So this computer will automatically set its default gateway to this address, link local router. How do you know, if you look at the two addresses, how do you know which one is the link local and which one is the public? Just by looking at the address. Can you tell?
Local link is FE80.
Exactly.
Octet.
Exactamundo, Jingo. So yeah, all the link local, I just wanted to test like how many people actually read. So FE80 is always the link local address. This is, I know, very easy. So any IP version 6 enabled router will send out messages in response to RS solicitation message. This is just how DHCP works. When you turn on your computer and you're configured and your IP configuration is to obtain IP address automatically, your computer sends a request to solicit the DHCP server, and the DHCP server respond. Same thing IP version 6 enable router does. Okay, so this is so a computer ask for solicit the router, and the router supply the IP address. You can configure the router with the DHCP server, sorry, yeah, DNS server, and what else? DNS server and DHCP server and default gateway, all this it can send to the PCI one. Okay. So here you see R1 replies with an RSRA message. So PC1, hi, I just booted up. Is there an IP router? Okay, on the network. Yes. He says, yes, I'm an IP router, and here is the SLAAC global unicast address, right? And it gives you the prefix. By the way, use my link local address F00 as your default router. So if the router and PC one can speak like human, this is how they communicate. Okay. Okay, if the address is duplicate, it's automatically detected. To check the uniqueness of an address, device will send another message with its own IP version 6 address. Okay. And if another device on the network has this address, it will respond with the NSA message notifying that the address is in use. This is something, this is not new. It's also in IP version 4, where if you assign an IP address, it's already used, it will tell you that it's the IP address is duplicate. You're duplicating an IP address, and this is ICMP message. And just like IP version 4, ICMP messages, IP version 4, how the MAC address is mapped to the IP address. What protocol does that? Cricket. What protocol convert map IP address to the MAC address? ARP. So ICMP messages also, okay, so they also convert MAC addresses to IP version 6 addresses, and that is used by ICMP messages. Okay. All right, ping and traceroute. You already know what is the ping command does. So here IP version 4, this is IP version 6. Ping also can be used to test internal configuration. Remember, we talked about the loopback IP address. What it does is it it, it tests if IP protocol is installed properly on your computer. Okay, and because that could be the problem. IP TCP/IP TCP/IP protocol is a software, and that just like any other software, it can also be corrupted. So this is, so when we were talking about troubleshooting, this is one of the things you can also do before you start checking cable or routers. Just ping this address, loopback address 127.0.0.1, and what it does is it checks if IP address is correctly installed. Loopback address for IP version 6 is just this, colon 1. Okay. A response, if you don't get a response, what do you, well, in Windows, you just uninstall. Here you can highlight and uninstall the TCP/IP protocol and install it again. Okay, we already talked about ping the default gateway. If there's if you cannot ping the default gateway, then you have to focus on the router. And what are you going to see on the router? Just go look at the interface that is connected. So in this case, G000. Just type show IP interfaces and check if the address is configured properly with the and the interface is up. To ping a remote host, if you cannot access a remote host, the problem could be with the router. So in this case, what you do is you use traceroute command. And what traceroute command does is it checks every hop or every network in between the source and the destination. So the problem could be the network 2 or network 3. Okay. Have you guys used traceroute command or not?
Yes, sir.
All right. So yeah, you see, so if you type traceroute 192.1, so when we cover the chapter about routing table, how to create routing table, you have to use this command extensively because you're creating the routing table and all your network must be able to communicate with each other. Like here, well, here there's only one router, but if there are multiple routers, all the devices must be able to communicate with each other. If one device is not able to communicate to another device which is on the different network, you have to use the traceroute command, and it uses one, two. These are called hop, meaning it goes, every router is recorded, and this is how you can isolate problem. Okay. So yeah, okay, yeah, this is here. So if you're pinging from here to there and ping fails, then you type traceroute. So you will see if it goes to, if the packet can goes to router 1, router 2. If it's successful, then there's no problem between these two router. If it fails here, then the problem is router 3. If it fails here, then the problem is router 1. So if it fails here, you just go to the router, and first thing you check is interfaces. If the interface is up, the IP address is correct, then you next you have to check the IP routing table. Okay, we haven't covered that, but in the routing table we have learned in previous chapter that the routing table contains of all the network that this router knows, directly connected and remotely connected routers. So if the route is missing in the routing table, then you have to focus on reconfiguring the routing table or add the route. Okay. So that's it. It's a short chapter. There are some labs about pinging, but don't think they're easy, because this is like, okay, I know you guys know what ping command does, and you can ping from one computer to another computer, and it's pretty simple if it fails. But when you have multiple network, you have to know how to approach, how to start troubleshooting, starting with verifying IP configuration on your own device, verifying configuration of the router, all the routers that are involved, verifying the configuration of the destination host as well. Okay, and then there's physical layer. Could physical layer also causes can well, a lot of time is the physical layer that's a problem. That's a problem. So either it's a cable, port on a switch, or port on a network card. All right, so yes, let me see.